All right, now we're looking at number 10. I had to erase A because it didn't work. I think I got it from the book and you need a calculator for it. You could do it, but it's not a good visualization of what's going on. So instead we're going to start with f of x is equal to sine of 2x. And we want to find where's it increasing, decreasing, where's any extrema, and where's it concave up and down, and where's any inflection points. So in order to do that, we take a derivative and we get 2 cosine 2x, take a second derivative, and get minus 4 sine of x. And the thing to keep in mind is sine of 2x is that you don't have to do this in this order. You can take the first derivative, find everything first, do the second derivative, find everything second. I kind of like taking both derivatives at the same time. So now for f prime of x, I can do a sign chart. But first I need to see where this is 0. So our initial interval is minus pi over 3 to 2 pi over 3. So if we look for zeros, we say 2 cosine 2x equals 0. This is f prime of x. So cosine 2x is equal to 0. So the thing inside of cosine is equal to 0 at pi over 2 plus pi k. So now divide by 2. X is equal to pi over 4 plus pi k over 2. Right? Your function changes twice as fast with the 2x, so you have solutions twice as close. Okay, so now we see which one of these are in the interval. So pi over 4 is in the interval. If I add in pi over 2, that's going to put me at 3 pi over 4, and that's going to be too big. So pi over 4 is in there, nothing bigger. Minus pi over 4 is in there, subtract pi over 2. And minus pi over 4 is smaller than, is closer to 0 than minus pi over 3, so it's in that interval. But these are the only two. So now I do my sign chart. Minus pi over 3, minus pi over 4, no commas, pi over 4, and then my last endpoint, which is 2 pi over 3. And now we have, luckily, just cosine, so not too much going on here. So if I plug in, say, something in the middle, let me find my calculator real quick. Here it is. I'm going to plug in stuff. Again, plug in any number between minus pi over 3 and minus pi over 4. So let's try, just for fun, minus, 5 pi over 16 should work. That should be between the two. And we get a negative number. If I plug in 0, I get 1, that's positive. And if I plug in something that's bigger than pi over 4, I'm going to be negative. So my function is decreasing on minus pi over 3 closed, because that's an endpoint, to minus pi over 4, union pi over 4 to 2 pi over 3. And it's increasing in the middle, from minus pi over 4 to pi over 4. So that's where that function is increasing. And now same idea, look at the second derivative. First let's find local maxes and mins. Local max. That happens when we go from plus to minus. We go from increasing to decreasing. So we have a local max at pi over 4, f of pi over 4. We plug that into our function. That's pi over 4 sine of 2 pi over 4. And if you work that out, that's pi over 4 sine of pi over 2, which is 1. And then similarly, there's going to be a local min at minus pi over 4 f of pi over 4 minus, which is equal to, again, if you plug this in, minus pi over 4 sine of 2 minus pi over 4, which will give you minus pi over 4 minus 1. So that's what's going on there. So that's our local max and min. This is where it's decreasing and increasing. And that solves part B. Or at least that solves where it's increasing and decreasing. Next up, we look at the second derivative, minus 4 sine 2x. 4 sine 2x, this is for concavity. And so we have, again, look for zeros. 2x is equal to pi k, because the zeros of sine are pi k. X equals pi over 2 times k. So we see how many of those are in the interval. Here pi over 2 works because it's less than 2 pi over 3. If I add another pi k, I'm at pi. That's too big. 0 also works. That's in that interval. And if I go back minus pi over 2, now I'm too small. So these are the only two zeros. And now we do the same thing. So concave up, concave down. We're going to use our sign chart to figure that out. So minus pi over 3, 0, pi over 2, 2 pi over 3. In our function, I have to be careful. There's a minus sign, so minus 4 sine 2x. So if I plug in something bigger than 0, say pi over 4, I'm going to be positive. If I plug in something bigger, say 2 pi over 3, I'm going to be negative. And same thing, if I plug in, say, minus pi over 6, I'm going to be negative. So it's concave up from 0 to pi over 2, concave down from minus pi over 3 to 0, together with pi over 2 to 2 pi over 3. And finally, where's the inflection points? That's where the concavity changes. Are at 0, f of 0, and pi over 2, f of pi over 2. So this is 0, comma 0, plugging into the original sine function. This is pi over 2, comma 0, plugging into the other function. Okay, so that covers 10a.